Welcome to the AI playlist. Hi, my name is Mohit Chabda, ex-Salesforce, ex-Walmart, and in today's video, we will talk about concepts like bias, variance, overfitting, underfitting, and regularization. So these concepts are frequently asked in interviews. So let's discuss about each of these in detail. Bias means error from wrong assumptions. So we make incorrect assumptions in this. It means the model is too simple to capture the real patterns. This model ignores the important features and makes systematic errors. Say for example, in actual there was a curve, but the model took it as a straight line. So basically in bias, the model will underestimate or overestimate consistently. Now after bias, let's talk about variance. In variance, the model is overly complicated. It makes errors as it is too much sensitive to the training data, such that it also gives attention to the noise. So what will happen is that model will perform very well for the trained kind of data, but it might be possible if you give it a new set of data, it might perform poorly on that. So now let's see bias and variance in one screen. So the left one talks about the bias and the right one talks about the variance. In case of bias, we have incorrect assumptions. The model is very simple. It ignores some of the important features. It consistently underestimates or overestimates the system and hence makes systematic errors consistently. In case of bias, there is also limited parameter adjustment, which means it is not learning from the data. It is completely ignoring some of the important features and not adjusting its parameters according to data. Whereas when we talk about variance, it is over complex model. Unlike the case of bias where there were limited parameter adjustment, here in variance there are significant prediction changes. It is too much sensitive to data such that it will also give attention to noise, and once it starts paying attention to the noise, it includes irrelevant data. So basically what happens is that it performs well on the trained data but performs poor on new data, and hence there is poor generalization. So bias is an overly simple model which ignores some of the important features and does not adjust its parameters, which means it is not properly learning from the data and making consistent systematic errors. Whereas variance is a case where the system is overly complicated. It is very much sensitive to data, and that's why it also gives attention to noise, due to which it can make significant changes in its prediction model. So it will be very good for the trained data, but it will be bad when you introduce it to the new data. So it is poor in generalization. Now after this, let's talk about underfitting and overfitting, which are related to bias and variance only. So underfitting is the situation which happens when the model follows high bias. That is, the model is too simple and it is not making good learning. It is not learning from the data. It is making a lot of systematic errors consistently, and in that case your model gives poor performance, and that is a situation of underfitting due to high bias. An example of underfitting is model is calculating the price of the property just on the basis of number of rooms. It is ignoring the location, it is ignoring the size. Just on the base of rooms, like there are 4 rooms, 4 BHK, it is increasing the price, but it is not taking into factors like what is the location, what is the total size of the property. All such important factors, these are getting ignored. So this is the case of underfitting, and you can see it will perform badly because it is only considering only one of the factors and ignoring other factors in it, and it is not learning on that basis. After underfitting, let's talk about another situation, which is overfitting. And overfitting happens when the model follows high variance. So the above case, we saw the situation of high bias which caused underfitting, and when there is high variance in the model, we get overfitting. In this, the model is overly complicated and model is too much sensitive to the data. So instead of learning the real patterns, it starts learning from the noise and it adds on a lot of irrelevant information. So what happens is this model performs very good on the given trained data, but when you introduce it to some new data, it performs very badly. So you can see in both the cases, underfitting and overfitting, there is poor performance. In case of underfitting, so underfitting is due to high bias, and overfitting is due to high variance. Now let's see overfitting and underfitting in one screen. So in case of underfitting, your model is very simple, whereas in case of overfitting, the model is overly complex. In case of underfitting, your model performs poorly even on the trained data. So you get poor training performance because the model is ignoring some of the important features. It is not learning from data. Hence it gives a poor performance even on the trained data. Whereas when we talk about overfitting, it gives excellent training performance. It works very well on the data on which you train it because it is very sensitive to the data, so it is observing each and every point in it very well. So on trained data, overfitting will give you a very good performance. Now talking about the generic data, that is when you introduce your model to new data which is unseen, you see poor generalization in both the cases of underfitting as well as overfitting. Why? Because in underfitting you never learned properly. The model ignored a lot of important features and did not update its parameters, so it will perform badly. Whereas in case of overfitting, it was too much sensitive to the data, so it was even focusing on the noise level, so it got a lot of irrelevant details. In case of overfitting, the model can make a drastic change in prediction based on the data. So based on the noise as well, it can modify a lot of parameters which is not required, and hence when the new data comes, it doesn't perform well because it appears more of a memorization of the trained data rather than learning the proper fundamentals or logics or the patterns. So when new data comes, it fails on that. So we saw here both underfitting and overfitting. But what do we want in real life? We want a sweet spot, the balance between underfitting and overfitting, and that we get using regularization. So basically we want to balance the complexity of underfitting and overfitting, that is of bias and variance. We neither want our system to be too simple nor over complex. We want a balance. So basically regularization is a solution to overfitting, because in case of overfitting our system was overly complex, so it tries to simplify it a bit. So it reduces the model complexity, it tries to make simpler model weights so that overall the model can become little less complex. Now it can reduce the complexity in various ways. Just if we see some of the examples, if you can see, pruning is one of the method which is used on trees, where it removes the unnecessary branches. And similarly there are other methods as well, like L1 L2 dropout, which works on linear models and neural networks. Now let's see in a summary kind of format what regularization does. So basically, first when we talk about bias, it means that you are making error from wrong assumptions consistently. You are ignoring some of the important features and not learning from the data. When we talk about variance, it means that you are too much sensitive to the data. The model is too much complex and even gives attention to the noise and makes changes to its parameters even for noise. When we talk about underfitting, it is a case when there is high bias, so the system is too much simple that it ignores a lot of features. It is not learning, like there is a curve but you are taking it as a line. When predicting the price of the property, you are ignoring the location, you are ignoring the size, you are just checking the number of rooms present in the property, and based on that you are just predicting the price. So high bias gives results to underfitting. And then we have overfitting, which means there is high variance, that is the model is too complex, it is too sensitive to data, and it is also making changes in the parameters based on the noise, which should be ignored. And what is the solution? Regularization. We try to simplify the overfitting situation so that the system is not that overly complex. You add penalty to reduce the complexity so that the system can become slightly simple in such a way that it can ignore the noise. It should focus on the real patterns and ignore the noise so that it becomes generic in nature and performs well even on the new data. So what are the effects? In case of bias, the model misses the patterns. because it is not giving attention to a lot of important features. It is not learning. So it will give poor performance in both the current training data as well as the outside unseen data. In case of variance, the effect is that it captures the noise. So it gives good performance on the training data, but it gives bad performance when you test it on the unseen data. In case of underfitting, because it's a result of high bias, so it will give the poor result on training as well as test unseen data. Whereas in case of overfitting, as it is because of high variance, so it will give good results on training data because it is giving very high attention to each and every detail of that part, but it gives poor performance on unseen data because its parameters have also adapted from the noise, which should have been ignored. Now what we want is regularization. The effect of regularization on overfitting is that it reduces the overfitting, so the complexity will decrease. It will now start ignoring the noise and identify the real patterns, and now it becomes very good in generalization. When you give it new data, now it will have good performance on that. So these 5 terms: bias, which means too simple, ignores a lot of important features; poor performance even on training data; variance, too complex, too sensitive to data, even gives attention to the noise and adapts its parameters to noise, which is not required. So good performance on trained data but bad performance on unseen data. Underfitting, it is a cause of high bias. So when the bias is high, underfitting will come. So very simple model will ignore a lot of features, poor performance even on trained data and even on unseen data. Overall very poor performance. Now talking about overfitting, it is caused by high variance. So very complex system, too much sensitive to data, adapts its parameter even to noise, which is actually not required. So it gives good performance on the trained data because it pays attention to each and everything in it. It is like memorization. You keep in mind each and everything of the trained data. So good performance on that, but poor performance when the model is given new data. Now the solution is regularization, which tries to simplify the overly complicated system, and this will give a good performance in generic to trained data as well as unseen data. Let's try to understand all of these with a simple example. So we are taking a real life example where student is preparing for exam. So bias condition would be student uses wrong formula, gets wrong answer no matter what. So basically student is ignoring the important feature here, that is the formula. Say we have a plus b square. Okay, the formula actually is a square plus b square plus 2ab. Okay, so this was the actual formula, but say student is applying some wrong formula. If student is doing a plus b square is a square plus b square. Okay, so this was actual, which was correct formula, but student was applying this formula which was wrong. So in most of the cases student will get the wrong answer even when doing the practice and in the exam, whatever the situation is, because the student is ignoring important factors and not learning. So the same mistake, it will give the poor performance even in practice and even in exam. Let's see the example of variance. Student memorizes practice questions. Okay, so you are given a question, you memorize that completely. So if that question is asked to you, you will give a correct answer. But if there is some variation in the question, the student might not do well. Why? Because student just memorized the thing, did not focus on the fundamentals or logics or the patterns. So when there is some new question with some trick added to it, student is unable to identify it, and that's a case of variance, that you are just memorizing the current data but not understanding the patterns. It is same for a lot of us when we give the interviews, right? We do lead code questions and sometimes we just try to memorize it, and when the interviewer asks it with some twist, we fail to solve it because we just memorize the solution. Instead, if we focus on the fundamentals, understanding the patterns, we will be able to solve even the new question, right? So after this, let's talk about underfitting, which happens due to high bias. So example is student didn't study enough and gets everything wrong. So if student applies this formula in exam, of course the result won't be good, right? So that is underfitting. And when we talk about overfitting, it is due to high variance. So in that case, student memorized the book, can't answer slightly different question. So in exam, a question came with a twist, student was not able to solve that. So student did well when the same exact question came, that is the trained data, does well on that. But when there is new data, new question, trick question, student fails on that part. That is overfitting. So what we want is regularization. We want to simplify bit overfitting into a balanced way. So in that case, student focuses on the fundamentals, logics and the patterns, not memorizing the things but understanding the patterns, so that it can be applied to even new kind of data and perform well even on new data. Here you can see we have the visual representation of these cases as well. First one is the underfitting. There was actually a curve, but you took that as a straight line, so you are ignoring a lot of important details and not learning from data. The other case is overfitting, that you are making your system overly complex, even focusing on the noise. So you can see it has overly complicated the curve. So what's a good fit? It's a regularization. You can see it was a simple curve. We neither want a straight line nor over complicated curve. So this is the result that we get from regularization. Alright, so in this video we covered a lot of fundamentals which are important in terms of interviews. We talked about bias, we talked about variance, underfitting, overfitting and regularization. So in case you have any doubts, put that in the comment section. I'll try to help you out. If you found this video helpful, press the like button and share it with your friends so that all of us can become AI pro. Alright then, this is Mohit Chabra signing off. Subscribe to the channel and thanks for watching.